Okay, so let's start. Very good evening to all our audience of ASP watching our monthly APOD live session from Astronomical Society of Penang. So APOD stands for Astronomical Society. Astronomy Photos of the Day, which is every day, which is a website that actually managed by NASA and a group of professional astronomers, and they will select photos from this submitted photos, and then they will share it on the page, the APOD page. So welcome everyone. So first of all, let me introduce our panel today. So as usual, we have Dr. Chong.
Hello.
The president of Astronomical Society, and me, Lai. And today we have two new friends joining us as the panel of discussion for APOD. All right. And first we have Yun Ming. He's a Form 5 boys in Hanjiang High School. And they will select photos from... Sorry. Yeah. And then he is from Hanjiang High School. And he represented Malaysia joining this International Remote Astronomy Olympiad. And won a bronze medal. I think it's 2 weeks ago, right? Last week or 2 weeks ago. Yeah.
Yeah, about that time.
Yeah. And also, his trainer was joined us last month in airport, Jachin, right? So, Jachin did train you in preparing for this Astronomy Olympiad. Yeah, so he's good in astronomy, so feel free to ask questions. All right. And also we have our APOD, our monthly APOD. We have did this APOD for about 1 year, more than 1 year. And this is the first time we have our ASP flower joining us, Miss Boon Wei Chiu. All right. So she's a graduate from USM, School of Physics. And she did her minor in astronomy. So she has excellent background in astronomy, so she can answer all sorts of questions in astronomy. So feel free to ask questions on that. All right. So as usual, if you have any questions, all right, please post it in the comment section in our Facebook page or through the chat session in our YouTube channel. All right. So let's begin with today's APOD. Let me share my screen. Okay, so can see my screen?
Yes.
Okay. So today's APOD is Messier 101. So Messier 101 is actually taken by, the image credit goes to NASA, ESA, NOAO, and CFHT. So when we say this kind of deep sky object, usually, all right, especially such deep skies like the galaxies, nebula, most of these photos are not taken from Earth, from the observatory on Earth. All right. Of course, there are some galaxies and nebula you can take from Earth, but usually, especially such big and clear image or big and clear photos of deep sky object, usually taken by this Hubble Space Telescope. All right. So this is the last Messier object recorded in the Messier catalog. So the Messier catalog, Charles Messier, as we know, a famous French comet hunter, and he did a catalog making record on all the objects he observed. All right, and in the whole catalog, all right, there's no comet found, but then there are galaxies, nebula, star clusters. So this is Messier 101, also known as this Pinwheel Galaxy. Pinwheel Galaxy, and you can find it in this constellation of Ursa Major, somewhere here. Okay, the Big Bear, Ursa Major. So it's somewhere near the Big Dipper or the Big Bear. All right. So this is the Big Dipper, somewhere over here on the tail of this Big Dipper is somewhere up here is the M101 galaxy. Okay. So a little bit information about this Messier 101 Pinwheel Galaxy. So it's a very, very big galaxy. It's about twice the size of Milky Way. Our Milky Way is 100 to 120 light years, but then this is about 170 light years in span. All right. So this image, as mentioned in the caption, you can see over here. is stacking up about 51 exposures. That means the Hubble Space Telescope, all right, it captures the image. There are 51 raw image and stacked together and form this image. All right, so this is not a raw image that at a simple time you just one shot and you can get the whole thing. All right, that's why we have these photo credits and this acknowledgement to all these authors in helping to produce or to generate this image. Okay, so this is about Messier 101. Next, let's proceed to the next APOD, okay, which is the APOD yesterday on November 26. So this is an APOD taken by Laurie Hatch. Laurie Hatch is an American professional astrophotographer, and she works in this Lake Observatory. So this is Lake Observatory, observatory owned by University of California. And inside this observatory, there's a very famous telescope named the James Lick Telescope. James Lick is actually not an astronomer, but he's a businessman. Okay, he's a businessman and he's very rich. So he had great interest in this astronomy. So he decided to donate his money to build this observatory and also the most powerful telescope at that time. All right, but the sad news is before this observatory and this telescope is built, is finished, is completed, all right, this James Lick passed away. So his body is actually interred on the base of this telescope. All right, so if you search for more images about this Lick Observatory, you can see there's actually a copper plate putting his name over here and is in memory of him. So this is the 36 feet long telescope. All right, 36 feet or 36 inch long telescope. All right, it's big. All right, so you see the human is just so small down over here. All right, it's a tiny, so it's so small over here. So this is the whole telescope. So which is looking from the bottom. Okay, you found this telescope. So this is on the event of this almost total lunar eclipse. All right, it's a partial lunar eclipse. Okay, but then it's very close to a total lunar eclipse, but it's not yet total lunar eclipse. So instead of calling it a partial lunar eclipse, some they prefer to call it a almost total lunar eclipse. All right, almost total eclipse phase. So this is it. The moon is over here and Pleiades is up here. And if you notice, all right, the background of this image, all right, this is the observatory, the dome roof, and then this is the telescope, and the background is reddish. So this is actually almost every observatory they use this design, right? They have this red light as their background. So why they choose red light is because in observatory, red light is just bright enough for you to look at the things that you need to do. All right, it's bright enough for you to see what you are doing. All right. At the same time, it can allow you or allow your eyes to adjust to the dark at night vision, so that at the night, if you use white light, all right, you work for some time, and then after that, if you look into the dark sky, it is a bit uncomfortable for your eye. So red light is just nice, all right, it's just nice, and it's actually more friendly to our eye when we shift to the dark or to the dark vision. All right, so this is about the APOD on 26th of November. All right, and yeah, Pleiades is up here. All right, the Seven Sisters. Okay, and we have discussed about Pleiades many times. All right, and next we have the APOD on 23rd of November. 23rd of November. So this is actually an image of the sun taken by this SDO, Solar Dynamic Observatory. So Solar Dynamic Observatory is actually there's a satellite up there imaging the sun. All right, the new star. All right, they call it the new star. So new star stands for Nuclear Spectroscopy Telescope Array, the new star. All right, so the SDO, every day you can observe or you can see there are different wavelengths of the sun. from the sun. So this is the based on the caption mentioned over here, right? This is high energy X-ray. All right. Featured here is the ultraviolet light shown in red. So the red one is the ultraviolet light, and then we have the blue one is the emission above the sunspot detected by new star in different bands of X-ray. So there's X-ray and there's ultraviolet. So in physics, or when we study wave, all right, we talk about light or we talk about energy. We talk about wave. So in wave, there are different wavelength. All right. So our eyes, all right, our eyes is sensitive to the range of wavelength about 350 to 700 nanometers. All right, somewhere here. Okay, we call it the visible light region or visible light spectrum. So there are 7 colors in this visible light spectrum. So all these color together, we seen it as a white light. All right, but if you have a spectroscopy, you can after diffraction, you can see there's different colors on this. All right, and this is the high energy region, which is the X-ray and the gamma ray region. This image. All right, and just sharing a little bit of experience when we do outreach. We bring this solar telescope and we bring to the kids, the primary school or the secondary school kids, when they see through the telescope with solar filter, right? That through the telescope with solar filter, you observe the visible light. So usually the response we get is we just see some white thing or a white ping pong ball. This is a response we get in solar observation. So that is actually visible light. All right, and there are many different different wavelength images, include the infrared or the X-ray, ultraviolet, or gamma rays. All right, so you can search for more. Okay, and yeah, this white one, all right, the white one over here, this one is actually visible light. All right, and if you want to observe this one, you need a hydrogen alpha telescope. All right, so that's it about the APOD from me for 23rd of November. So next, I'll pass to Dr. Chong to proceed with the APOD.
Thank you, Mr. Lai. All right. So I'll share now. Lai, can see already, Can see my screen,
Yes.
Okay.
Yes.
So now November 21st, introducing Comet Leonard. All right. Now you see, Malaysian being Malaysian, they don't know how to pronounce. They'll say Comet Leonard. No, this is an English name. It's called Leonard. All right. The O is silent, so Leonard, Comet Leonard. So this is an interesting one because this is C-/2 2021 A1. That means this is the first comet discovered for 2021. The first one, and it's discovered by one guy called Greg Leonard, or named after him. All right. So when it was discovered, I'll make it smaller now. Okay. So when it was discovered, it was not seen at the orbit of Mars, was not seen clearly. But they predict that by December next month, naked eye visibility can see by naked eye. But now you can see beautiful. You can see here the bright coma, the green coma, and then you don't see the nucleus, but right in the center you see just a part which is very bright, which is just around the nucleus, and you can see the tail. All right. So basically here, what you call, so it's now brightening now. All right, but taken by Dan Bartlett, an American astrophotographer in California. Right. So now the thing is this: why are comet usually green in color? It can be explained because this comet, the part of the comet that is solid is called the nucleus. It's very small only, a few kilometers in size, but it will evaporate, coming out what you call gas and dust, forming a coma. Why does it evaporate? The solar energy, the heat, and the solar radiation will hit the frozen nucleus, evaporate it, and it form a coma. And because it's moving in space, the solar radiation and the solar energy keep on hitting the coma, so it develop a tail. And because the fact that usually in most of the comet, in the comet and tail, you have these 3 important molecules. One, of course, Why not be a comet and breed, no? Why isn't it attached to each other with a covalent bond, and also triatomic carbon? Three carbon atoms attached to each other with covalent bond. So because of this, what we call cyanogen molecule, diatomic carbon, triatomic carbon, the electrons that are going around the nucleus of this carbon atom, nitrogen atom, as they have transitioned, they give off green light. So that's why it's green, the existence of cyanogen, all right, radical, diatomic carbon, and triatomic carbon, all right. So like this, okay. So now we go to the next one. 19th of November. This is very interesting. All right. It's very interesting. Okay, this is processed by a Dutch guy called Guido Olmensa. All right. But the data is taken by Chandra, the X-ray telescope, the big famous what they call NASA telescope Chandra. So basically, the Chandra telescope many years ago observed the universe. So it observed the stars in purple color, which is X-ray. All right. And then Spitzer is in red. So basically now, very interesting is they took a picture of this, what they call NGC 81, all right, with a narrow band filter, meaning that they only let light in narrow band to go through. That's why you see this green, blue here. It's because of the narrow band filter. And when you took the narrow band filter, there are many of the stars which is captured by the narrow band filter in white light. So what they do is they have a computer algorithm that remove the stars in white light. So there's no more stars there after they remove it. But then after that, they took the pictures taken by Chandra, which is in purple, and put it to replace the other visible stars. So now the purple stars are the X-ray stars. And the red stars are by Spitzer in infrared. So basically you see the X-ray stars and the infrared stars to replace the visible light stars. That's why it's called starless. Starless meaning originally they have this, you call it the Pac-Man Nebula. There's a lot of visible light stars. They have the software to remove the visible light star, and then they added on the X-ray star and the infrared star. That's why you call it, all right, starless with star, all right. There's something call it the Pac-Man Nebula. Remember, I don't know whether Bunwei and Junming, you are familiar. About 30 years ago in Penang, when you go to the arcade, you play the Pac-Man, you know. That means
yes, remember.
this what they call Pac-Man, well, what they call the kind of a small like this
yellow monster,
like this emoji, like your Android one, you go and gobble up, makan, eat up the all those things lah. So it's called Pac-Man. So this look like a Pac-Man Nebula. I call it Pac-Man Nebula. Right?
I'm just 20 something. I'm not even 30 yet. So I'm not familiar.
Oh, okay.
When the Pac-Man came in Penang, I know what, go Jelutong, everyone go crazy about Pac-Man.
But I remember there's a anime or something recently, right?
Yeah.
How impossible you cannot know.
So that's why I like this, is because the astronomers like to give interesting name. Welcome to the Zooniverse, the astronomical zoo. All right. So January the 18th, right? All right, here I will make it larger first, the script. Then later on I make it smaller. Of course, the moment you see it's taken by Jeff Dye. Oh, don't play. Jeff Dye is a very young guy. This is the World at Night group of amateur astrophotographers. Jeff Dye is they claim that he's the youngest member of the World at Night group. All right, and Jeff Dye has his friend Jingji Wu. No? So basically like this. I'm still now doubting whether this is Jingji Wu or Jeff Dye. I suspect the person standing on the hill here is Jeff Dye. And the person taking the picture is his friend Jingji Wu, right? So you may say it's nothing so scientific about the picture, but it's artistic. So it's like this. Normally, when you stand under the moon, I take a picture of you in next about 2-3 meters from me, and the moon above your head. The moon is very small, because the moon is far away. But now what happen is Jeff Dye now is going very far away from his friend Jingji Wu. So I estimate now that the distance between the photographer and and depth is about 5 kilometers. So, and in that case, the size of the moon is bigger than the human being. So I repeat, if you look at a person in front of you with the moon behind, the moon is small, the person is big. But as you go further and further away from the man and the moon, because the moon size actually remains the same all the time. So what happens is, you go further away from the man and the man rate of decreasing size is faster than the rate of decreasing size of the moon. The moon doesn't decrease so much. So the man will decrease very fast. So at a certain distance, I estimate that this size of the moon compared to the man, the photographer is about 5 kilometers from Jeff Dye. And just very nicely, they put it such that the moon is bigger than him. And you can see here, can you see our Jeff Dye with his camera stand, with his camera? You cannot enlarge it. You can see him with like on the camera stand with the camera. All right. And that's it. And they took a shot of this. I think this is a single shot. A very nice shot, all right? So it might be just correct, all right? And then they must have practiced it sometime during the daytime when to take this picture. So this is what? This is our full moonlight. Jeff Dye here under the moon, all right? And they didn't say where is the place taken, okay? Of course, this being China amateur astrophotographer, it might be in China, all right? So now we will continue. We go to Bombay. Pass over to you.
Thank you, Dr. Chong.
Yeah, okay.
So let me share my screen. Window. Okay, share now. Give me a minute.
Yeah.
It could be some technical problem there. Okay, I'm not sure whether you can see or not. Okay, so I'm sharing the airport photo taken on the it's taken on the 19th of November, which is just now light shed on the almost total lunar eclipse under a telescope, right? Now we share I shared about the almost total lunar eclipse at the zoom site and also with the playlist here. Yeah. So for this photo is actually taken by the Robert Ferdis, and this is actually when the lunar disk is not entirely immersed in the Earth data, because this is one partial lunar eclipse. So actually you can see why is this photo so special is because of the darkness of the lunar eclipse is like let him can capture the playlist together. So I think it's a very, very nice compilation because actually I still thinking and wondering how to take the photo with moon and the star together with the with this telephoto snapshot because I think the lens could be very, very high zoom as well. So another photo I would like to share is also another lunar eclipse happened on the same day, which is on the airport on the 20th of the November.
Wow, beautiful.
Yeah, this one is a very, very beautiful.
Yeah.
This is taken by Yuri Beletsky, who is an professional astronomer in the he's now at Chile, and he actually now is also work under a Las Campanas Observatory. This building is the Grand Torre Santiago. It's actually the 62-story tall skyscraper in Chile and also the tallest building at North America. Yeah, sorry, it's South America, and very, very difficult to take this angle because have to wait all the time when the moon is right above on the skyscraper and everything. Maybe we can try a day find to get this type of the photo to take on Comta maybe.
Yeah, good idea.
Yeah, this is a very good idea, I would say. Yeah. So then I would like to share on another one, which is another one is the, I'm not sure can see or not. I want to share on the 16.
Yes.
Oops, it looks like I cannot go into that tape. Have to go, sorry. Uh-huh. Window. I would like to share this one. Actually, it's my favorite sky event.
Yeah. Wow.
This one, yes, this is the Geminids from Gemini. Yeah, actually, the Gemini meteor shower is my favorite sky event, and almost every year I will go and have the look one. But you can see this one is very nice compilation where we can see Orion, Milky Way, and also the Geminids from the radiance. And this photo is taken on 2020. And the Gemini is showing like 200 bright meteors straight through the sky. But actually, I wondering how this Wang Jin, the photographer, take this, because I still remember I got tried to take the Gemini meteor like last time in 2017, which I go with you, Dr. Zhang. You still remember that?
Yes, sure.
We go to the Pusat Ilmu Falak, and then we saw a very bright orange fireball straight through from, I think, until the east to west sky, and last very long. That was I very remember on that one. And then I also will bring my camera to take the photo, and I share you my photo taken is like this one little one here. And yeah, and this is the Gemini. Actually, it's quite lucky lah, because I can get a Gemini and a small little Gemini's meteor here. But this one is like, I think it will be stacking a lot of the Gemini photo, or maybe their sky condition is very nice. Yeah. So after this, I would like to almost forgetting. In this year, actually the Gemini's meteor shower will be happen in also the 14 November, but it's actually at 3 p.m. noon. Yeah, but maybe we could have some time to before the sunrise and after the moon set, which is about like maybe 5 a.m., 4 a.m. something. We can try to go to have a watch on the Gemini's meteor shower in December 14th. Yeah. So then I would like to share another one is on the 15th. Sorry, stop sharing again. I don't know what happened to my computer.
Never mind, we do it. Yeah.
Okay. So another one I would like to share is the APOD on the 15th of November. Is the screen already out?
Yeah, can see. Yeah.
Okay. Yeah, this one is the light pillar that happened over the volcano Etna. Volcano Etna is actually a very active volcano in Italy, and actually I think it's erupting in June, and in the past week, I from the website said that from the news said that it is actually less calm now. So this picture is taken by I don't know how to read his name because it's a French name
Yeah.
or Italian name.
Italian name.
Italian name, yeah. He is actually a photographer and a video
Yeah.
maker. So he actually took a very very well photo, and there's a eruption that happened in also mid of June, which is the erupting volcano is the erupting time. And actually it show a very very, they said in the YouTube showing that the beautiful sunset eruption. Just the sky and everything is quite beautiful now. Yeah, and under the eruption, actually it produced light. So how this light pillar can be shown is because you see this is the light source and the fire source, right? And because of the ashes that evaporate in the Mount Etna, and also they forming actually when it's cools now, actually they form a ice crystal on the volcano. So how these light pillars form is because they are actually like this one. This is a assume that this is a volcano, and then because of the ashes from the volcano, right, it actually becomes a many mirrors, forming a lots of mirror. And when we are seeing here, at we look at the sky, it see like a light pillar. Yeah. So this is actually how it does. So the photographer is here over here, and the volcano and the fire's light source, and with the ashes here, they when the light is reflecting under this ice crystal, and we look on it, it like forming this light pillar. This kind of the phenomena is actually quite I would say, I think it's quite normal lah, because we can actually see it um if if sun, we call it as a sun pillar or something. Yeah, so I could see a lot lah because of the reflecting of the light under a very dense clouds. Normally it will happen on during the sunset, I guess. And many this one is a sun pillar. Yeah, I think it should be around sunset or sunrise, I'm not sure. Normally when I pass through the Penang Bridge, I can sometimes I can see. Yeah, and there's this one are the volcanic volcanoes eruption. Yep. So then I will pass to another one. Yep.
You name?
I stop sharing.
Yes.
Okay.
You're on, you mean?
Yes. Okay, I know. Sharing now.
Yeah, we can see you, we can hear you.
Okay. So the picture I'll be presenting first will be the November 14 picture, which is how to identify the light in the sky. Now, as you can see, the picture shows a diagram for anyone to opt to identify what the light in the sky is. It is, and this is by HK. The illustration credit is by HK. This is very largely accurate, such as example, the part saying that it is really big. Because most astronomical objects have an apparent diameter of not more than 5 arc minutes, except for the Sun, the Moon, and our neighboring galaxy, the Andromeda Galaxy. Moreover, another part that's very accurate will be how a fireball is much brighter than a meteor. If this was false, then the upcoming Gemini meteor shower on December 13 will be very easy to see even in brightly lit city areas. And it is also very true that a fireball is much brighter than a meteor, as mentioned by the previous APOD tour, where it is brighter than a planet and the fireball has shadows. However, as it mentions in the explanation, there are still some inaccuracies. Of course, as a word of precaution, you should not be burning your retinas while looking at any light in the sky. In fact, you shouldn't look at the sun directly. Moreover, contrary to the picture, stars and comets actually move. Now, if we can observe a star for a few hours over time, you'll notice that it seems to rise and set. This is mainly because the Earth rotates. Of course, stars themselves move, and over hundreds and thousands of years, we can see them move due to various factors such as precession and redshift. However, for the most part, stars are relatively stable over 1 year period. And another exception to this chart is that and is that we see an artificial satellite moving. While this is true for most satellites, however, a geostationary satellite will be different. This is because geostationary satellites have an orbital period of 24 hours, and so they remain stationary to a single point on the Earth. They will not appear to move to an Earth-based observer. Likewise, comets also move as well, and if we can observe them for hours or days, we will see them move. And finally, for this picture, I don't think we can see astronauts waving at us from the Earth. However, for all intents and purposes, this is a very good picture by HK. Now on to my next picture, which is the November 11 picture. This picture is called Stellar Nursery in Perseus with image credit to Michael Sherrick. This picture shows NGC 133, which is a reflection nebula. Now, what are reflection nebulas? Reflection nebulas are nebulas that shine due to reflection. The nebula has and does not produce any light, which is a bit like our moon. Nebulas are also clouds of dust and gas. As you can see in the diagram, the light is reflected off the dust cloud and it enters our eyes. This light tends to be polarized and bluer because dust grains, or rather the dust grains in the cloud, tend to scatter blue light more efficiently than long red wave light, which gives a blue color for these reflection nebulas. Interestingly, the size of the reflection nebula is not the size of the gas cloud, but rather the area which is illuminated above the point of detection. Picture, you can notice that the Pleiades are here, the 7 stars, which is also Messier 45. We can see them over here, and these Pleiades are to the northwest of Taurus. Interestingly, we can also see the same picture when we search for NGC 133 with NASA. This is the Pleiades and this is Taurus. In fact, if you notice from the picture earlier on, This is near the constellation Perseus, and so we can deduce that this picture is taken somewhere in this triangle, most likely over here. Now, on to my next picture, which is the November 9 period picture. Over here, we can see a 15 by 15 array of pictures. Now, why out of so many pictures would the APOD be a compilation of pictures? What is it trying to tell us? The answer is to allow us to understand our real universe. This picture is created, or rather, it's credited to M.J. Smith, and as the title suggests, all the pictures here are not real, but one. This is to allow for our software to better detect phenomena in the universe. Try to guess which picture is not fake. The answer, as will be shown here, would be the Crab Nebula. Okay. Where am I? Sorry, just now something went wrong. Yes, this picture, the Crab Nebula, or Messier Object 1, which has been mentioned in the previous APOD tour. Now, this Messier object is a supernova, which was first recorded and seen in 1054 AD. This Messier object rotates at a speed of 30 times per second and has an apparent magnitude of 8.4 and is located 6,500 light years away from the Earth. So when we see this Crab Nebula, we notice that there's lots of different colors. These colors correspond to the elements and atoms that form this object. It's not what we'll actually see if we can visually see this Crab Nebula. As you can see over here, orange part is mostly hydrogen, the blue part is mostly neutral oxygen, green is single ionized sulfur, and red is doubly ionized oxygen. Now on to my fourth APOD picture that I'll be presenting today will be the November 7th picture. This is the Cat's Eye Nebula in optical and X-ray, and credits go to NASA ESA, Hubble Legacy Archive, and Chandra X-ray observation. This is a planetary nebula, and we note that there are different colors over here. The purple colors are to show the X-ray radiation. That is, the purple colors are the X-ray light that was captured by the Chandra Telescope, whereas the reddish light and all the other colors would be the optical light that is captured. Now, for some background knowledge, how is the planetary nebula formed? Planetary nebula form from stars. This occurs when the star depletes of hydrogen. The star uses up its hydrogen, and as a result, the radius of the star increases, and it becomes a red giant. In this process, the star will shed most of its outer layers that would eventually leave behind a hot core that will soon contract to form a dense white dwarf star. As layers are shed, the star is seen to expand and contract, and these shed layers would then form the planetary nebula you can see. And why do we see these shells? This is because as the hot core pushes outwards, a fast wind is ejected. A fast wind rams into an ejected atmosphere and pushes it outwards. This creates the shells we can see over here. Of course, what is interesting is that this will also be the fate of our sun, which is a main sequence star. And it is estimated to happen in about 5 billion years' time. But why do we see X-ray emission from a star? This is because shock waves are created as the fast wind collides with the ejected atmosphere. And so, this is a very beautiful picture. And that will be it for my APOD presentation.
Right. Next, we have Boon Wei.
So it's me again.
Yes. Welcome back.
Yeah. Come back. So I would like to share my screen to talk about another airport on the 6th of November. Yeah. So is the screen out? Okay, so this one is the airport on 6th of November 2021, which is actually taken by Martin Lefrance. Okay, so actually this one photo is actually from actually can see from his Instagram. He's a photographer, and all these friends something. Yeah, he actually said that these photos is him and one of his friend go to one day hike in Lake at the Plateau de Emperors. Yeah, so Plateau de Emperors is actually a very, very beautiful place. In altitude is over 2,000 meters and in France. So they went to a hike, and then at the 2,400 meters altitude, definitely the sky is very, very clear. I went to a Rinjani also the same, and of course it could be very dark, as you can see. Three elements. You can see many stars. Actually, you can see a very obvious three elements here. So what is shown in this image is actually as also is captioned in this photo. We can actually see the Milky Way, the Andromeda galaxy. This one. Andromeda galaxy is actually the nearest neighbor to our Milky Way in about like 2.5 million light years ago. And actually, you can also see very, very clear if under a dark sky, you can see visible. You are able to see with your naked eyes. So I believe M31 is taught a lot in the airport already, so I'm not dig into this. So another galaxy could be able to see in this image, which is a second nearest spiral galaxy to our Milky Way after the Andromeda galaxy. Actually, these two galaxy is actually quite near. Based on this stereo, you can see that this is the Andromeda, and then another one is actually almost somewhere here. Is the M33. This one is the Triangulum Galaxy, and about 2.73 million light years from Earth. So, guess where is it? It's actually happened at here.
Yes, in between them.
In between of them. So
Mm.
in this photo, you can see like 3 galaxy is our local group galaxy in one image with 2 friends here standing here. Very very nice idea. Maybe can so nice.
That galaxy will be the biggest light bulb.
This one is it?
Yes.
Yeah, and it's mentioned in this caption at these two they are actually standing about 3 light nanoseconds apart. Actually it's a 30 cm lah if under conversion after using the formula of the light. Yep. So after this maybe I would like to share something is next or satellite on our also in the local group galaxy, and also this one is the next is a how to say satellite galaxy. Yeah, let me share it the photo. Wait a minute. Oops. I think. Okay, I think I got a problem. I have to stop sharing and reshare. Okay, so this one is NGC 147 and also NGC 185. So it's taken by Dan Ballet, is a amateur astronomer. So this photo, this one is the NGC 147 and this one is the NGC 185. This one is actually a satellite galaxy of the Andromeda. It's also part in our local. Just now we said about the local group galaxy, right? It's also part of it. So this is actually taken with a telescope Celestron RASA 11-inch and with a camera on something this and taken on 10th of October. You can see the details here. So actually in here we can see quite many of the sky. I think this is grand already. Yep. So this one NGC 147 and NGC 185. So NGC 185 it also call it as a Cadwell 18. It is a dwarf galaxy, and also we call it as a Stafford galaxy. Type 2 Stafford galaxy is here. Taken by the NASA. This one is discovered by, in 1787 by the British astronomer William Herschel. And this is actually quite easy to spot if you would like to see under binocular under a dark sky. You can actually see it. Another one is a NGC 147, which is also called as a Cadwell 17. It's a dwarf galaxy located about 2.5 million light years. Actually, this galaxy is observed later than NGC 185. It is discovered in September of 1829, and Yeah, it's actually these two is near to the Cassiopeia constellation. If you want to see them, this NGC 147 is a bit fainter compared to the NGC 185. Yeah, but it is actually somewhere just lompat something. Yeah, so these two galaxy, they are actually forming they are actually a binary galaxy that has forming a gravitational stable binary system. Yep. And they actually also found something fake dwarf galaxy Cassiopeia 2, and seems to be part of them have formed a gravitational bond group in this. Uh Actually, I this is the paper study in this, but I do not want to read all. So in conclusion, they are actually found in they are actually gravitational bound group. They are gravitational bound. Yeah. So after this, I would like to pass to Dr. Chong.
Thank you,
Yeah.
Bunwei.
Stop.
Okay. So I'll share my screen. Right, can see my screen, huh?
Yes.
Okay. So November 2nd, SN standing for supernova requiem, a supernova seen 3 times so far. So requiem for the religious people, it means it's a kind of religious ceremony to commemorate the dead people, the past people passed away, a kind of music to commemorate people who have passed away. All right. So let's see what it is. Interesting, huh? Okay, the moment I know lah. This is massive gravitational lensing. So basically, what we have here is, so this is good information is the picture by Hubble Space Telescope. Of course, Hubble always means NASA and ESA joined together. All right, NASA is the American Space Agency, ESA is the European Space Agency, and ESA is not a single European country. Many European countries joined together. All right, and by Dr. S.A. Rodney, astronomer, associate professor at University of Southern Carolina in USA. And processing done by J. De Pasquale from STS here. STS here means Space Telescope Science Institute. Hubble Space Telescope. And remember, we are now all waiting for December 18. And James Webb Space Telescope is going to be sent. And James Webb Space Telescope also will be controlled by STSCI. Space Telescope Science Institute in Baltimore, Maryland, University of Johns Hopkins. So basically, you have this here, a supernova called AT2016 JKA SN Requiem. All right. And so basically, the what I call the supernova exploded behind this galaxy cluster in front. This galaxy cluster called MACS J0138. So this is the intervening means in between galaxy cluster, and this star exposes a supernova behind it. We don't see the galaxy behind it. What we see here is a kind of a mirror image. That means as the light from the star behind, the galaxy behind, passes through. When I say pass through, doesn't mean light pass through a glass, no. Bent by the gravitational field of this galaxy cluster. Now remember, this is a galaxy, for example, our Milky Way galaxy diameter is 100,000 light years. So this could be millions of light years. So the galaxy with the star, the exploded supernova behind, we don't see. But as the light comes nearer to us, this in between galaxy cluster will bend the light. And in 2016, we see the 3 spots of light coming from the same supernova. How do they know? So basically, they'll study the spectrum of this spot here, the spectrum of the star. When they say spectrum, spectrum with respect to time, the evolution of the spectrum. Here also the same. So they know that actually the points of light here are coming from the same supernova behind this galaxy cluster. Right? And then they found that Hubble again in 2019, 3 years later, they observed it again. Hey, there's no more light. That means the supernova after 3 years died out. Right? But they they also can map the distribution of the mass distribution of this galaxy cluster. So from the computer simulation, they say that in the year 2037, 16 years from today 2021. So in 2037, 16 years from now, they will suspect that the supernova that give the light here in 2016 will again appear in 2027. How come? How come? Like this. That means the distance of the light from the supernova bent by this galaxy cluster, the distance bent by the light is the same, so you can see them the same. But the distance bent by the light, bent by the gravity of this galaxy cluster is longer. So it takes longer, all right, longer time to be seen. That's what. So now in 16 years' time, what? Hubble no more in working lah. Maybe James Webb is working, or maybe a powerful telescope on the Earth will look here, and if they see, there's a spectrum of the light there, 2037, and the characteristic of the spectrum is similar to the one in 2016. That means that they are actually 1, 2, 3, 4, actually from the one and the same star in the galaxy behind. So this is our massive gravitational lensing. Now we know that not only light can pass through the galaxy cluster bent by light can measure. The light can be bent by many degrees. Light can be bent by the sun. 1919, all right? Total solar eclipse, light bent by the sun, and discovered that gravity can bend light. Einstein became famous, and they have discovered that light radio wave can be bent by planets. So theoretically speaking, as I stand in here now, the light from behind is bent by my own gravity in my head, but the amount of bending is very big. It's called micro lensing. But I think maybe they have equipment on the Earth now. The light passes through Comta, beside Comta. Imagine the whole of Comta is surrounded by vacuum, no atmosphere. So as the light passes close to Comta Tower, the light can be bent by the concrete in Comta, can be done. All right. So that's it. So now I come with a prediction. So far, according to the general theory of relativity, gravitational lensing has been predicted and found. But so far, there's nothing to say that this cannot be seen, can be seen. Look here. I have here a bundle of optical fiber. But now we look at it in a different way. Imagine this is not optical fiber. Is that here, basically, this is the light wave coming from, let's say, a galaxy far away, passing here, and the light is being bent not by the, normally in the optical fiber, the light is scattered by total internal reflection. Okay, so if this is a bundle of optical fiber, so from the left to the right here, they arrive at the same time. But imagine this is a gravitational lensing. So I mean, as the light from behind is emitted, we pass through different gravitational field. So by the time they come here, they arrive at different times. So that's the case for this one, right? They arrive at a different time here. So it's possible. So I think according to general theory of relativity, this cannot be, this is possible, meaning that you have a light from behind the star and it comes past by the galaxy cluster, they bend the light, and this light is actually emitted earlier, right? So as the light emits earlier, the path of travel is shorter. So this, mistake. The light emitted here is, imagine here there are two events, event A and B. So event A occurred earlier, all right? Event B occurred later, right? So now what happened is the light here is caused by event B, the event that occurred later. That means as the light, all right, passes from the event that occurred later, the move bent by the gravity of the galaxy cluster, but the path travel is shorter. So by the time we come here, it arrives earlier. But event A here, which occurred earlier, bent by the gravitational wave, and in such a way that the light traveled by the event A is actually a longer distance. So it arrived here later. So in other words, what happens is that you can have two events here. The event that occurred later arrived earlier. The event that occurred, earlier arrived later. So that means, according to general theory of relativity, imagine we can see a few spots of light. Right? It doesn't mean that here of course 2016, 2019 means here earlier, here later, 3 years later. But it's possible according to general theory of relativity, you can see spots of light where here the event occurred later, right? Arrived earlier. And here the event occurred earlier, arrived later. So if that's the case, it means that imagine behind there's an alien. Alien. That means you can see two pictures of the alien. This one you see, imagine today, this is when the alien was older. The picture of the older alien arrived earlier. And the picture of the younger alien arrived later. So it's possible. So far, this scenario have not been discovered, but there's nothing that say it cannot be done. So in future, we are waiting for gravitational lensing where the later event will arrive first, the earlier event will arrive later. So you can see a person, all right, imagine there's an alien, the older alien image will come earlier, the younger image will arrive later. This is against normal understanding of our intuition, but it can occur, all right? This is what I say, welcome to the weird universe, right? So that's very interesting. So we wait for 2013, 16 years from now. We hope that there you are, another spot of light will occur. 2016, 3 spot. 2019, no more here. 2037, it will arrive here, like this. So this is our massive gravitational lensing caused by galaxy cluster, right? I think, okay, next one. November the 1st. Okay, there's nothing scientific about this. And what I like about APOD is beautiful. Okay, I repeat, the name is a waterfall and the Milky Way ZG. A Messier astrophotographer from China. I make it smaller now. So it's in a place in Hunan, eastern Hunan province, Lujiao, what they call mountains, be the waterfall. But there is some composition. So basically, the waterfall here normally is very dark. You don't see a single thing, very dark. So if you were to, this is a long exposure camera photography, no telescope. You put the telescope somewhere away from the water, the bottom of the waterfall here, the lake here, and then you expose it for some minutes. But it cannot be too many minutes. If too many minutes, the star trail, the star will move. Maybe maximum of 2 to 3 minutes, so that no star trail. And then you see Milky Way and you see all the stars and constellation. And then you see it's a kind of like a cave. You see the treetops here, very nice. And then the waterfall is as if the waterfall is flowing down from the Milky Way. So nice, all right, very ingenious. But of course, there's a trick here is that if you go there normally, this whole area is dark. So he put a light there, and he exposed it for say 2 or 3 minutes. That's why the jungle and the waterfall got light. If you were to take the picture instantly, you don't see the waterfall as a line, gilly looking, funny looking. If you take an instant picture, you see the water falling in lumps, not like smooth flowing thing. This shows that long exposure, 2-3 minutes. So here you have Milky Way, all right, and you have the summer triangle here, all right. You have Vega star in Lyra constellation. You have Deneb in Cygnus constellation. And out there in the Aquila constellation, the Eagle constellation. So very nice. You have the Earth, you have the water, feng shui, and then you have the Milky Way and the stars. So nice, all right. So this is really a very nice idea of this person, ZG, all right, in Hunan province, all right. So I think that's all for me. So Lai, you want to wrap up? Then I can wrap up.
We don't have any questions so far from both Facebook and YouTube. All right, but I have one question for Dr. Strong. Back to the Comet Leonard just now.
Yeah.
Because usually comet we see 2 tails, but why this comet it seems like we only see 1 tail?
Yeah. Okay, I'll go back again. Thanks for asking. November 21st. Can you see that, right?
Yes.
Okay, so basically like that, what we understand that from the Earth, when you say you look at comet with naked eye, with camera, or with telescope, or with big powerful telescope, and you can even maybe see it with not only optical telescope, maybe radio telescope. So comet can have no tail, no coma. One possibility. It has seen before. Why? Too far away from the sun. Beyond the orbit of Mars, say the orbit of Saturn and Uranus, there's only a point of light, the nucleus, no comma, no tail. So you have possible no comma, no tail, or sometimes it's small comma, no tail, still very far away from Mars. So that means the sunlight and the sun's heat will evaporate the ice in the nucleus, give a small comma, no tail yet. Now we come close as Mars, you have a small comma and a short tail, and so on. So now here you can have one straight tail, or you can have two tails, or sometimes you have a so-called third tail, the false tail, the anti-tail. Right? So, but I'm not trying to say, but like if you look carefully, even I look at it, it looks like, you look at my cursor, this is the first tail, the first tail, the straight tail, the so-called ion tail, and this is the curved tail, the curved tail. Can you see that's a kind of a curved tail there? So this is the dust tail, right? So basically, most comets we have two tails, where they're closer to the Earth, to the Sun as the distance of Mars, and even closer. So the ion tail is that the solar wind, the Sun's electrons and protons and ions, IONS. Ions means atoms that have lost electrons. So they will hit the particles in the evaporator from the comet, and they'll hit it at tremendous speed. You know what is the speed of the solar wind? I think it's thousands of kilometers per second. So hit it, and these particles, they have a lot of momentum. They move in a straight line. But sometimes you have a crooked dust tail. So dust tail is what? Much bigger particle. Dust lah. The dust on the feet, major floor is not so clean. So those dust particles are the size of the dust particles in the dust tail. So again, the sunlight, the solar wind hits the dust particles here, but the dust particles are much bigger than the electrons and protons. So the dust particle will move slower. So now the ion tail moves past straight, all right? And then here, the dust will be curved like that lah. So this is it. But here, basically, like you say, you can see basically about one tail lah, the ion tail. So in other words, if you ask me, this question, I can answer you straight away. Can we find, they have discovered thousands and thousands of comets, all cataloged. Can we find two different comets that behave exactly the same? No. They have different characteristics. Some got tail, some don't have tail, and so on. Right? Even if you have some of the comets like that also, they come from the original source, also do not behave the same. For example, 1994, our comet Shoemaker-Levy number 9, there's a big nucleus of a comet passed by Jupiter, and Jupiter's gravity was strong broke off the comet into 22 fragments and came back and hit the Earth 9 months later. So comet train, one big comet becomes 22 comets with many tails. You look at them, they also behave differently. They all come from the same comet, mother comet, right? So they are not the same, right? So that's this lah. So in other words, that's why I used to tell my USM students when you do stargazing or in my astronomy class, say that the universe is what they say. The universe not perfect one. Nothing in the universe is perfect. You can never have in the solar system a planet that orbit around the sun in a pure circle. Impossible. You can never have the exoplanet orbiting around the other stars in exact circle. Impossible. So the universe is not perfect. Right? Even the Earth is a sphere. No, the Earth is an ellipsoid. The north and south diameter is shorter than the equatorial diameter because of centrifugal force. They pull out the bulge, right? So not perfect lah. So how to understand the universe? The universe is not perfect. That's what it is.
But the imperfect brings the beauty.
No, I never said that the imperfect is not beautiful. Imperfect brings variety. Beautiful. Yes, I get it lah. Yeah, the universe is not perfect. As it is lah. Yeah.
Yeah. But, so far we don't have questions from both sides. So I think maybe Dr. Chong, we can wrap up the session.
Yeah. So I just wrap up is we are now waiting for the two big events. Okay, sorry. Oh, sorry. Okay. So thank you, Michael. So two big event. Now our ASP is organizing on the 14th of December, Gemini meteor shower observation in Lim Chung Kiat Observatory in Pulau Batung. And I will be there, right? But the day earlier, 13th of December, it seems the USM Museum and Gallery got some funding. They're also doing, not open to the public, to tourist people. So we expect to get about 100 people from tourism people in Penang and KL to come. Of course, our ASP member, USM Astronomical member, Yun Ming, would be all that come lah. About 100 of
I
them.
definitely I will come because the
Ah,
Gemini
we-
is my favorite
we
sky
observe.
event.
So we expect to get about 10 to 15 telescopes there. So 13 or 14 of November or December, Gemini in Pulau Betong, Chungkiat Observatory. One day earlier, 13th of December, Gemini shower observation in the Museum and Gallery of USM. All right, and remember, the Gemini meteor shower is very broad. The peak is very broad, not like the earlier one, very narrow. All right, so Perseid and so on very narrow. So this is broad. So plus 1 day, minus 1 day is still good lah. So 13, 14, the most important thing is good weather. But slight problem, Bombay, 10-day-old moon. That's a problem. Got
Yeah.
10-day-old moon, yeah. So unless you see the bright meteors, can see lah. All right. The dim meteor maybe you miss unless you
Maybe I wait until the next day. Oh.
no, the next day, the day on the 13th is a 10-day-old moon. On the 14th in Chungcheong place is 11-day-old moon. More brighter. The moon is brighter. Never
Yeah.
mind. So whatever. So what I'm saying is that we hope that the most important is the weather is good. You take picture. All right. So if you come to the museum, I just saw that the WhatsApp they put right. Listen you mean Bombay, free flow of food and drinks.
Wow.
Free flow of food and drinks. So that's
Can
what
go in public can go in.
They are okay. They open to our museum staff, our ASP members. You must those coming must let me know. Yunming also, and then also USM as club member. And of course the big one is everyone listen. I talked to our David already. Our Junjian, he agreed that if they allow it, Michael, listen, 18th of December, launch of the James Webb Space Telescope. Look at that. Oh, 22nd. Oh, okay. In that case, maybe Junjian and I, we do go on the 22nd. Remember, look at my face. Bombay, I waited for 14 years since 2007. Keep on delay. So now, of course, now it's, I think, being integrated. The telescope is integrated to the Ariane 5 rocket in Kourou, the SR spaceport in South America. So we hope, so everything will delay. So we hope that November or December 27. Don't delay until 2022 2021. All right. So we want to see the first light, the first picture from. So in future, Yunming and Bombay no more Hubble. No, in future will be web. Web, infrared, right? You can see further into space. But I was waiting for them to announce American. They announced it. It was a big letdown. The James Webb can see further than Hubble, but the James Webb cannot see into the dark ages. Remember when the Big Bang occurred, pure energy. After that, you have this inflation, and then you have the electron, proton, and hydrogen atom form. The first atoms were formed, then the first galaxy were formed. Right? But before the first galaxies were formed, the star formed, there was pure light and formed the atom. So there are hundreds of millions of years. The universe was dark, no stars, called the dark ages. So as you see with the Hubble, now your Hubble can see about 400 million years after the Big Bang. So James Webb can see maybe about 200 million years before the Big Bang. But you cannot see the dark ages. So in future, got another telescope see further than James Webb, can see the dark age, not yet the Big Bang. So hopefully, again in future, they'll build more telescopes, can see the Big Bang itself, the moment of creation of everything. So we hope. So sorry, James Webb cannot see even the dark ages, but good enough. It will make a lot of discovery. And remember, they have been saying in even the many of the professors as well say that the discoveries by James Webb will rewrite the astronomy textbook. Rewrite. Not change. Rewrite the astronomy textbook. So we hope. So thanks, Michael, for reminding. So we hope for 22nd. So if Junjian and I, it's okay. If Michael agree, we do a short presentation of the launch itself. All right. About the type of technology they use to build up the James Webb Telescope, the detectors, and the rocket. And the very important, the 30 days of terror. Not the 7 minutes of terror. 7 minutes of terror is when America launched their Curiosity and their Perseverance rover, and China launched their Tianwen one rover to land 7 minutes through the Martian atmosphere to land safely. But this one is from the Earth, they sent to the L2 Lagrangian point of the Earth and the Sun system, and then from there you open the mirror to observe the universe. So it takes 30 days to go there, and everything must open according to plan. So we hope it will work well. So that's it. So
Yeah,
now
I think we share the details on the discussion on that day.
yeah. 22nd of December. So we wait lah.
Yes.
Yeah.
yes. But
So
at
wait,
the same time, we have any upcoming events beside I think our Astro Cafe and our
Yeah.
next
So
report.
anything on, Michael?
Yeah, we
Like
have
who,
a workshop, right?
Oh yeah, Derek.
Oh, on taking the photography one.
Yes, it's an astrophotography workshop organized by ASP, and our instructor is our member, Mr. Derek Lim, Dr. Derek Lim, right?
Yes.
Yeah, from he's currently in Bangkok. So will he be back, or he will conduct it from Bangkok? Yeah, it's online, so he will conduct it from.
So
Yes.
just to add on to you, on coming Monday, I and Dr. Kuldeep, our vice president, we're going to meet the personal assistant Encik Abdul Rahman of the new governor. All right.
Yeah, that one, Dr. Chong, that one later.
Oh, not really. Okay.
We are still on live session.
Okay.
All right. So if that's all, then I think we can call it a session. So that's all for today's APOD session. Maybe we see you next week.
Yun Ning and Boon Wei stay back. Short discussion.
So thanks for
sure.
joining us tonight. So see you again in the next APOD section next month.
Thank you, Michael. Thank you, Lai. All right.
Thank you, everyone.
Boon Wei
Good night.
and
Bye bye.
Okay, bye. So stay back.
Bye.
Okay.